Thanks for checking out Pocket Roni. Actually, if you can look at this problem right here, we have 4 over square root of 2 plus 9 over square root of 5. So now we are going to be adding and subtracting fractions that have radicals in the denominator. Okay? But in words, here are your steps to do it. Okay? The first thing you do is get rid of the radical in the denominator in both fractions. Okay? Then number 2, since we are adding and subtracting fractions, you always have to have a common denominator when you are adding and subtracting fractions. Once you have a common denominator, step 3 is combine the numerator. Once you have your numerators combined, then you always look at the end, anytime you're dealing with fractions, can you reduce fractions? Can you reduce the whole numbers? And then when you're dealing with radicals, can you simplify the radicals? Okay? So I will repeat these steps 1 through 4 as I'm working out 19A9. Okay? So the first step in words was to get rid of the radical in the denominator. Okay? The way we get rid of the radical is to multiply the radical by itself. So working with this first fraction, we have to multiply both the numerator and the denominator by square root of 2. Okay? So this new fraction, numerator times the numerator, 4 times square root of 2 would be 4 square root of 2. Square root of 2 times square root of 2 is square root of 4. We're adding. Our second fraction, we have to multiply it by square root of 5 to get rid of the radical in the denominator. So our new fraction is 9 times square root of 5 all over square root of 25. Okay, now we simplify the radicals in the denominator. 4 square root of 2, square root of 4 is 2. 9 square root of 5, the square root of 25 is 5. Okay, now we're still adding fractions. So this is the point we need to make a common denominator. Our common denominator would be 10, which means we need to multiply this first fraction by 5. So we multiply the numerator by 5 and the denominator by 5. Our second fraction, we need to multiply it by 2. Remember, in multiplying numbers and radicals, it's numbers to numbers, radicals to radicals. So this new fraction will be 5 times 4 is 20. My square root of 2 stays all over 10. My second fraction, numbers to numbers, 9 times 2, 18, square root of 5 over 10. I now have a common denominator. The third step was to combine the numerator. So I can rewrite the numerator all over one denominator. Okay, so I can say 20 square root of 2 plus 18 square root of 5 all over 10. Okay, this is not anything different than if I had 1/2 plus 3/2. I can combine my numerator. 1 plus 3 is 4. Okay? The difference is we now are dealing with radicals. So in remembering the rules of radicals, when you add radicals, you have to be the same kind. So we cannot add square root of 2 to square root of 5. So we leave it like this. The last step was you look to see if you can reduce whole numbers or simplify your radicals. I cannot simplify square root of 2 any more than that, and I cannot simplify square root of 5 any more than that. So now I look to see if I can reduce my whole numbers. 20, 18, and 10 can all be reduced by 2. You can only reduce your numbers if you can reduce all 3 of them by the same thing. I can reduce all 3 of them by 2. Okay? If I reduced all of them by 2, if I reduced 20 by 2, that would be 10. Leave your radical. If I reduced 18 by 2, that would be 9. And if I reduced 10 by 2, that would be 5. And that is your final answer. When you are reducing, let me show you, when you are reducing, it's the same thing as you're factoring out. Let me show you how this works. Okay, let's go back over here. Let's say I'm going to factor a 2 out from here. If I pull it out to the side, then it looks like this. And then if I factored a 2 out here, it would be 2 times 5. And your 2's cancel. And that's the same thing as what I did here. I just reduced every number by 2. instead of showing it in factored form. And you get the same answer. Okay? Let's go to 19A, number 10. Same steps. You're going to do the same step every time. The first step is getting rid of the radical in the denominator. Okay? So I have to multiply this by square root of 10. So now my new fraction will be 5 square root of 10 over square root of 100. My second fraction, I'd have to multiply it by square root of 8, both the numerator and denominator. So my new fraction is now 3 square root of 8 over square root of 64. Now I want to simplify these radicals in the denominator so I can get rid of the radical. So this becomes 5 square root of 10 over 10, 3 square root of 8, and then square root of 64 is 8. The next step is make a common denominator. Okay? Looking here, I can turn both of those into 40. I know that. My common denominator can be 40. So in order for this to be 40, I need to multiply it by a 4. So remember, numbers to numbers, radicals to radicals. 4 times 5 is 20, square root of 10 over 40. In order for this denominator to be 40, I need to multiply it by 5, the numerator and the denominator. Now, numbers to numbers, so I'll do the 5 times 3, which is 15, square root of 8, all over 40. I now have a common denominator, so my next step is, number 3 step, is to combine my numerator. I write this whole thing over one denominator. So I say 20 square root of 10 minus 15 square root of 8, all over 40. I look and see square root of 10 is not the same as square root of 8, so I cannot subtract them. So I leave it like this. So the next thing I look for is, can I simplify my radicals? Okay. Are there any perfect squares in the factors of 10? No. Are there any perfect squares in the factors of 8? Yes. 8 can be broke up into 4 times 2. So this can become 20 square root of 10 minus 15. Break that into square root of 4 times square root of 2. That's still all over 40. Okay, we're going to see if we can squeeze the answer down here. So there's my 20 square root of 10 over 40 minus radicals to, or simplifying the radical of square root of 4. That would be 2. So it would be 15 times 2 times the square root of 2 all over 40. Okay, now I can multiply these numbers together. So this fraction stayed the same. 20 square root of 10 over 40. Oh, let me back up a step. This is all supposed to be written over one denominator. Minus all over 40. Minus, combining our numbers to numbers, that's a 40. 15 times 2 is 30, and my radical 2 stays. Now at this point, my radicals do not simplify anymore, but I look at my whole numbers. Can I reduce 20 and 30 and 40 by the same thing? I can reduce them by 10. So reducing each by 10, 20 divided by 10 is 2, 30 divided by 10 is 3, and then 40 divided by 10 is 4. And this is my final answer because I cannot simplify any radicals anymore, and 2, 3, and 4 cannot be reduced any more than that by the same number. Okay, now we're going to do 19C 8. 24 square root of 13 over square root of 3 plus 3 square root of 2 over square root of 3. Remember, the first step is to get rid of the radical in the denominator. In order to do that, you multiply it by itself. So we need to multiply this by square root of 3. Also do the numerator. This one, same thing, square root of 3, both the denominator and numerator. Going to the first fraction, rules of radicals, numbers to numbers, radicals to radicals. This is like a 1, so 24 times 1 is just 24. square root of 13 times square root of 3, square root of 39, all over square root of 9. Square root of 3 times square root of 3 is square root of 9. The second fraction, numbers to numbers, 3 times a 1 over here is 3. Square root of 2 times square root of 3, square root of 6. The denominator, square root of 3 times square root of 3, square root of 9. Now we simplify the radicals in the denominator. So you have 24 square root of 39 all over square root of 9 is 3, plus 3 square root of 6 square root of 9 is just 3. Hallelujah, we have the same denominator, so you do not have to make a common denominator. You already have one. So step number 3 is combine the numerator. So you can write 24 square root of 39 plus 3 square root of 6 all over the same denominator. Look to see if you can combine your radicals. These radicals are not the same. Square root of 39 is not the same as square root of 6, so you cannot combine them. So then the fourth step is look to see, can you simplify the radical? I cannot simplify square root of 6 anymore. There are no perfect squares in that. And there are no perfect squares in square root of 39. Okay? Now the last step then is also you look to see, can you reduce your whole numbers? Looking at 24, 3, and 3. Can they all reduce by the same number? And all 3 of them can be reduced by 3. So we divide 3 into each number. 24 divided by 3 is 8. And we leave our radical. 3 divided by 3 is 1. You leave your radical. And 3 divided by 3 is 1. Anything divided by 1 is just itself. So the 1 does not need to be written. So you can just write your answer as 8 square root of 39. And you do not have to write the 1 in front of the square root of 6. So you can write the answer like that, because you cannot combine square root of 39 to square root of 6.